Inverse functions are functions that undo each other. So for example, if we're talking about things that undo each other in math, addition and subtraction are inverses of each other. Because if I, let's say that I take some number and I add 5 to it, if I take that and I subtract 5, it's like nothing ever happened. All right, when the x is in the exponent, so like all the examples that we did in lesson 1, where we're trying to solve equations where the x is in the exponent, we need these things called logarithms to undo the function. So exponential functions and logarithms are inverses of each other because they undo one another. So what we're going to do is we're going to practice writing things back and forth between logarithmic form and exponential form. What's really nice about logarithmic form is that you'll know it's logarithmic form because it literally says the word log in it. So this is what logarithmic form looks like right here, where I'm putting a blue star. The way that you say this is log base b of a equals x. And sometimes I've seen teachers kind of say it's like a heart almost. The way you rewrite it, I'll rewrite it first. It looks like this. B to the x equals a, and the way to remember is you make this heart. It kind of looks like a heart, I don't know. So you start with your base b to the power of x equals a. And this is something you're just going to have memorized. But eventually it'll get to the point where you've done so many of them that it won't seem like such a big deal. All right, we're going to rewrite these logarithmics, expressions, equations into exponential form. So the first thing we're going to do is, remember, we always start with our base. It's the base to the exponent equals this number. So this is going to be 3 squared equals 9. And one thing I really like about these is because it should make sense. 3 squared is 9, so they're equal to each other. So if you come out with an equation that doesn't make sense, you know that you did something wrong. All right, for number 2, here's my exponent, or I'm sorry, my base that goes to this exponent, and it equals 216. So 6 cubed equals 216, and if you put that in your calculator or if you have it memorized, 6 cubed is 216. So that makes sense. All right, for number 3, 7 to the 0 power equals 1. And remember, that was one of the properties we talked about in lesson 1. Anything to the 0 power always equals 1. So what's kind of cool is that anytime you have an equation like number 3 where it equals 0, that's always, when you put it back into exponential form, that will always be your exponent. All right, number 4 and 6 are you-try problems. So we'll skip to number 5. So remember, it's 4 to the negative 2 equals 1 over 16. 4 to the negative 2 equals 1 over 16. And remember, anytime that you have an negative exponent, it's always going to give you a fraction. All right, now we're going to go backwards. So now all of our answers are going to have log in them. So the log is always, the little number next to the log is called the base. That's always going to be the base of your exponential. The big number, the 196, will always be the big number in your log. It won't always be 196, but the number that it equals. And then it always equals the exponent. So that little number is always going to be the number on the other side of the equation from log. All right, for number 2, I'm going to have log base 3 of 81 equals my exponent, which is 4. So if you can remember that the base is the little number next to log, and that it's always going to equal the exponent, then the other number just has to fill in the last blank. All right, for number 3, log base 12 of 12 equals 1, which is the exponent. And then the last one we're going to do together is number 5. This would be log base 2, that's my base here, of 1/8, and then it always equals the exponent, which is negative 3. There are two special types of logarithms that we're going to talk about. The first is called the common logarithm, and that is a logarithm that has base 10. And what's special about it is that when a log has base 10, you don't have to write it. It's assumed. It's kind of like if you have x, you assume that the exponent is 1. You don't have to write it. So secretly there's a base of 10 when you see that the base is missing. In your calculator there is a log button, and that represents common logarithms. So you do that differently than you do a logarithm that has a base other than 10. So for example, if you have a problem that says log base 42, that's the same thing as writing log base 10 of 42. It's just that you don't have to write the 10 because it's assumed that it's 10 if it's missing. The other kind of special logarithm is called the natural logarithm. And that one is abbreviated ln of x. Sometimes I like to write it in cursive because otherwise you can't always see. It looks like in, but it's actually ln. So secretly there is a base of the number e, which you may or may not have heard of before. E is a number kind of like pi. It's approximately equal to 2.78. There is a button on your calculator that represents e. So if you go to the, in your calculator, there is an ln button, and that is what you use when you need to use a natural logarithm. Natural log of 42 can also be written as log base e of 42, just that whenever the base is e, we have this special notation that we use ln instead of log base e. All right, so now what we're going to do is take these equations and we're going to rewrite them in exponential form. And these are all equations that are using the special types of logarithms we just talked about. So remember that if you have log and it doesn't have a base, you should assume that the base is 10. So this would be written as 10 squared equals x plus 1. For number 3, now we're going to rewrite this in logarithmic form. The reason I knew that we were going into logarithmic form is because this does not have the word log in it. So we're just converting it back and forth depending on what they give us. We're trying to, our answer should be the opposite. So this one is going to be log base 10, except that now I don't have to write the 10, of 92, and it equals the exponent, which is x. All right, for number 5, this one is natural log. So what that means is that the base here is really e. So this is e to the 5th power. Remember, e to the 5th power equals 3x. And now for number 7, I'm going to go backwards. So I'm going to be doing, I'm going to put this in logarithmic form. So since I have base e, I'm going to do the natural log of 24 equals the exponent, which is x plus 2. All right, now we're going to talk about evaluating logarithms. Your calculator, depending on the calculator you have, it has different capabilities. If you just have a scientific calculator, so that means one that does not do graphs, you will need to know how to use this change of base formula. If you have a graphing calculator, those calculators will do logs that have bases other than 10. So I can show you how to do that on your calculator. So depending on what calculator you plan on using on the test, you should make sure you understand how to use that to evaluate logs. All right, so this change of base formula, if you have a log, base b of a, and b and a will be numbers in these problems, the way that you can change them into base 10 using your calculator is to do the log base 10 of a divided by the log base 10 of b. So this allows you to just use the straight log button and still get the correct answer.
To find the value of a log on Desmos, you have to use the change of base formula. So if you go over to where it says FUNC for function, you'll notice that on the bottom right you can see this is where you would use a natural log, and this is what you would use for the common log, which is base 10. So if I wanted to find log base 2 of 100, I would have to use the change of base formula. So I'm going to do log, which is base 10, of 100. Now to get back to numbers, you have to click on main. So I'm going to do log of 100. It's very important that you close your parentheses. Divided by, and you'll notice that it also automatically puts this into a fraction, which is really nice. Now I have to go back to function, and I'm going back to the common log, and I'm going to put in a 2. Close my parentheses, and when I press enter, or even before I press enter, you can see what my answer would be, which is 6.64385,619, and you'd be told what to round that to. But this is how you would use the change of base formula in Desmos to answer what is the log base 2 of 100. On the TI-84 Plus, in order to calculate logarithms, there are 3 different ways you can do that. If you're looking at a common log, which means it's base 10 or the base is just missing, and you assume it's 10, you're going to use this log button, which is to the left of the number 7. So you just hit the word log. It opens up parentheses for you. And let's say I wanted to know what is the log of 1,000. So I'm going to type in log of 1,000, and when I press enter, it's going to give me the answer, which is 3. And then because you know how to convert back and forth, if you wanted to check to see if you were correct or double check that it makes sense, you could say the base, which is 10, to the 3rd power, which was your answer, and when you press enter, it gives you 1,000. So you see that it checks out both ways. If you wanted to do a natural log, you would use the ln button, which is to the left of the number 4. Let's say that I wanted to do the natural log of 10. So I would type in 10, and when I press enter, it's going to give me this messy decimal. Now, if I wanted to check my work, when you do natural log, it's base e. So I could do second ln, and that gives me e to any power. And then if I wanted to type in my answer exactly, I could do second and then the negative sign, which just puts the answer right in. You don't have to type out the decimals. And then when I press enter, I can see that it gives me 10, which is what it should. Now, if you wanted to find log of any base, the way to do that is to press alpha window. So alpha is the green button, and then window is the second gray button from the left all the way at the top. And you're going to see that if you arrow down to number 5, it says log base, and then in blue you can see what it's going to look like. So when I press enter, or you can just hit the number 5, it gives me kind of a template, so I can just type in whatever I want. So I'm going to say, let's evaluate log base 6 of 36. And when I press enter, it gives me 2, and that's because if I take my base, which is 6, and I square it, because my answer was 2, it should give me 36. Now, you can use this log of any base, even for common logs and natural logs. It's just easier to use the log or the ln button for those. But if you have any base other than 10 or e, you can always use alpha window to get your answer.
Hey guys, this is a short video in my TI-30XS Multiview calculator tutorial series. In this video, I'm going to show you how to find the log with any base on the TI-30XS Multiview. Without further ado, let's get to it. So unlike the TI-84 graphing calculators, the scientific calculators don't have a feature that lets you do the log with any base. The standard log base is 10. So when you want to do the log of a number using this feature, the base by default is 10. Let's say you want to find the log of 15 with a log base of 2, for example. The way to do it would be to do log of 15 divided by log of 2. So type in log, and this appears on the screen, log 15. So just close the parentheses after you type in 15. So this assumes that the log base is 10. Now divide that by log and then 2 and close the parentheses. So this is log of 15 with the base of 10 divided by log of 2 with the base of 10. When you press that, the answer comes out to this, which is the same as log of 15 with the base of 2.
Hello and welcome to HP Calcs. I'm Rick, and today we're going to look at how to find logs on the Texas Instruments TI-30XS calculator. To do this, we'll be using the log key located here and the LN or natural log key located here. Now in this calculator, the default log base is a log base 10. So if we wanted to find a number that was log base 10, we would simply press the log and then enter the number we want to find the log of. So if we wanted to find log base 10 of 100, we would go log 100 equals 2. Easy enough. We can do something similar with the natural log if we wanted to find the natural log of a number. So say in this example 100, we press the LN key, enter the 100, and press equals, and we get the natural log of the number. But what if we wanted to find a log base that isn't 10 or natural log? To do that, we can use something called the change of base formula, which means we divide the log of the number we're trying to find by the log of the base we're trying to use. So, for example, if we wanted to find log base 2 of 100, we would follow this. We would enter log of 100 divided by log 2 equals. And this gives us the answer of log base 2 of 100, which is 6.643856, etc.
Okay, I'll keep this real quick. I want to find log base 5 of 15,625, and we want to find log of 25. If the base is not given, remember it's 10, so that's really log base 10 of 25. Let's do this on the TI. So if we, on the TI, the first one was log base 5 of 15,625. The log, this key here only shows ln, natural log, and log base 10, and which is called common log, I believe. So if you hit this button once, you get natural log. You hit it again, you get log base 10. If you hit it again, which isn't even on that button, on the label, you get log of any base. So log base 5 of 15,625 equals 6. And the second problem was log of 25, which is log base 10. Rather than wasting my time typing a 10, I just do this one, which is defaults to, or has a log of base 10. Put in the 25, we get our answer.
With this video, what we're going to do is find what this logarithm equals, simplified in other words, using the help of our calculator. And this one's going to focus on the TI-Nspire. Okay, and with the TI-Nspire makes it very, very easy. We just type it in just exactly like we see it here. So let me bring in a TI-Nspire here. Here we go. Let's see if I can move this over just a little bit closer here. All right. On the TI-Nspire, the logarithm button, there are two different routes that you can take. I always show students this one, the one right next to the book here. It's got a bunch of these squares. This one is like a go-to one. If you'll notice, I'll bring this in just a little bit further. We have a lot of different things here that will work. Okay, and this one here that's highlighted in blue is the logarithm one. Okay, so we'll do that one. Just type in that button here. And then let me move it back over here so we can see it. And again, we have a lot of information found there. That's not the shortest way, but it is one that works for many different applications. Okay, so I've got this one. It says log base 7 of 8. So all I'm going to do is type in 7. Let's see, the 8 is up here in the parentheses essentially, and then I just hit enter. Okay. Now, as I hit enter, you notice that it gave me this reduced form of the logarithm. Well, that's great, but what I want is a decimal. So the way I'll do that is, remember right above this enter sign is the approximation sign. Kind of looks like bacon strips. In order to get there, we'll hit Control Approximation. Then it gives me an actual decimal. And this particular one here asked me to round it to the nearest 4 decimals. So 4 decimals on this one would be 1.0686. 2 would require us to round down. So going back to this one here, The answer on this one should be 1.0686. Okay, now I'm going to do one more. Now this one is a log, and let's say 12.2. We have to remember what the base on this particular one is. Remember, whenever it does not list it, that's the shorthand for the log button, log base 10, excuse me. So I'm going to bring in my calculator again here. Now this one was 12.2. I can use this same button over here that we did. That works out really nice. However, there is a shorter way to do it. If you notice right here, I have all these buttons. Let's escape out of that. I have all these buttons here. One is an LN, so if you need to find the LN, you just go Control. This button will give you LN. Instead, I'm going to go Control this one, which will give me log. And this one is a log base 10, 12.2. Then I'll just hit Enter, and it gives it to me there. I have to round it to 4 decimals. 1, 2, 3, 4. The 3, let's see, that would turn into a 4 because the 5 would round up. So it's going to be 1.0864. So 1.0864. Now you're going to do the exact same thing if this one said LN. For some reason, if you need that, you're just going to hit this button instead. Control, and then this button will give you the LN, and that's it. But that's how you'll find it using the TI-Nspire.
This is a quick video just to show you how to change the base for different logarithms. When we press the log button, usually it's just working in base 10. So we get those sort of answers. But of course we want to change the base to something else. Very easy to do. First of all, what you've got to do is just have a quick look at the bottom, see what the different options are here. And here, these are not the options that we want. So I'm going to repeatedly press Exit until I get back to the standard menu. This is what you would usually have for the 4 different options. Going into Math, we can see straight away log to base A of B. So we can do log to base 2 of 32. And there's our answer. And there you go.
All right, if you have a graphing calculator, you can type these problems in exactly how you see them, and it will take you straight to the answer. So what I'm going to do is write out what you would need to do if you do not have a graphing calculator. So we're going to use that change of base formula, and I'm going to write this down again just so that you can see it. So the change of base formula looks like this. Log base B of A equals log of A over log of B. All right, so for problem number 1, your A is 64 and your B is 16. So what you would type into your calculator is the log of 64 divided by the log of 16, and your calculator will give you the answer of 1.5. For problem number 2, you would type in log of 1/16 over the log of 8, and your calculator will give you negative 1.3 repeating. For number 3, log of 2 over log of 5. And remember that these logs all have base 10. These are common logs that we're using. It's going to give you a decimal. I'm just going to write down the first 4 decimal places. Okay, number 4. This one, you don't have to use change of base because the base is already 10. So this one, you just type into your calculator exactly how you see it, and it's going to give you 2.4683. Same thing with number 5. You don't have to do anything special because it's already a natural logarithm, which there is a button for on your calculator. So you just type in ln of 13, and it's going to give you 2.5649. That's good enough. All right, and then number 6, you do the same thing. It's a common log, base is 10. When you type this into your calculator, it's going to give you an error. What that means is that you cannot find the log of this number. And you'll see that, especially, it'll make a little more sense when we do graphing, but you can never find the logarithm of a negative number. So automatically, when I saw this was negative 12, I knew that this was not going to give you an answer. So what we're going to do is we're going to put a 0 with a slash through it. That means that there are no solutions.